Hello everyone. If you have ever been stuck with any difficult limit, derivative, or integral problem, then you're going to want to stay tuned because I'm going to show you how to solve any of these with just a few simple lines of code in Python that anyone can do. 9.5 meters below space and time. This crash, so how much interest? Well, I'm going to take this vector equation. Welcome back to our Math in Python series here on Physics Teacher. Today we are doing episode 5, where we are going to look at how to solve limits, derivatives, and integrals. So I've started off here by plotting a function, 1 of x, and if you don't know how to plot functions, you can check above to go watch one of our previous videos in the series. So here I have this function, and I want to know what value does it approach as x approaches infinity. Now looking at this function, we can see it looks like it approaches 0 as x approaches infinity. But to be sure, what we're going to do is going to introduce a new limit function in Python. So here I've imported our plot function and our symbol function, but now I'm also going to import a limit function and a capital S function, which we are going to use to define infinity for Python. So I have this, and now I'm going to say the limit of, so this is 1 over x, so I'm going to type in that function, 1 over x, as x, so comma x, approaches infinity, so comma, and now infinity is capital S dot capital I infinity. Okay, and then you have to do it. Okay, now if we hit that, nothing's going to come up. It will do it, but we have to tell it to print it. So if I type print all of that, and then it will tell us that limit. So if I hit play, you can see down here the limit is 0. Okay, so we were right. But let's try something a little bit more difficult. What about the function sine x over x? So if we want to do sine x over x, what we're going to have to do is the following. So I'll have to import a couple things. I'm going to have to import simpy to be able to tell it what the sine function is. I'm going to get rid of the range, or the domain, I should say, and I'm just going to have it plot then simpy.sine of x divided by x. And I'm going to get rid of this line for now, and we're just going to plot this function. All right, so there's our sine x over x function. Now what I want to know is what's the limit of this function as x approaches 0. Now from this graph we can see it's 1, but if we were to try and solve that algebraically, the limit of sine x over x as x becomes 0, is it really 1? Or is it undefined at this point? Well, even if it's undefined at that point, it certainly looks like the limit approaches that from both left and right side. But we can tell Python to do this for us. So we're going to do the limit, and I'm actually going to import sine from simpy as well to be able to use in our limit function. So the sine of x divided by x as x approaches 0. Dot do it. And when I do that, oops, sorry, this shouldn't go into the plotting import, just in from simpy, so sine. All right, so it's all done. All right, but again, it didn't show up because I have to print it as well. So let's print so that we can see what that answer is. And there it goes, 1. All right, so now let's look at derivatives. So let's get rid of all of this. Now let's say you had an equation. Let's start with a simple polynomial, like maybe a quadratic that you might see in physics with a function, a position function of time. So let's say we have 5t squared plus 2t plus 8. Okay, and I wanted to find the velocity with respect to time. So to do that, I have to find the derivative. Now you could use limits, And you could use the limit function that I showed you and just set up an equation for your difference quotient. Or you can use the derivative function. So that's what I want to show you here. So what we're going to do is from simply, we can import symbol. We always need that one. And the function derivative with a capital D. And instead of x, we're going to use t for time. It's a physics question. So we're going to label that as our symbol t. And our equation, our position with respect to time, so I'm going to just write dt. So our function d with respect to time is going to be, I said 5 times t squared, so 5t squared, plus 2t plus 8. So there's our function, there's our position function, and if we want to find out the function of velocity, we need to find a derivative for that. So I simply need to type derivative of that function dt with respect to t. So I'm going to do comma t, and we end that with dot the do-it function. Okay, so that'll work. It won't print anything though, so to get it to print, let's do a pretty print there. So pretty print that whole thing. And when we do that, we hit run. Oh, I forgot to define pretty print. All right, so pretty print, run. There we go, 10t plus 2. Now you can see that that works because this is just a simple derivative with the power rule in a polynomial, but you can do the same thing. You can type any function in here and then solve for its derivative. Okay? And what I can even do is, instead of pretty printing that, I can say that's velocity with respect to time. And then I can say, okay, what's acceleration with respect to time? Okay, acceleration with respect to time is the derivative of velocity with respect to time. Dot do it. There we go. I don't need these brackets here. And then I can choose to pretty print VT, and I can choose to pretty print AT, and I should get both. There you go. Velocity is 10t plus 2, and acceleration is 10. So with this syntax, you can take the derivative and the second derivative for any function you want to type in here for dt. Right? If you want to know all the basic commands you can type in for a mathematical equation, you can go back and watch our first video in our Python series. Okay, but for now, we're going to move on to integrals. All right, so for integrals, let's get rid of some of these. We're going to start over here. I don't need the derivative function. I'm going to keep symbol and pretty print, but I am going to import the integral function with a capital I. And I can do, for example, Hooke's law. So Hooke's law, or the force, is k times x. So let me use the symbol x, and I'm also going to use the symbol k. So k equals symbol k. Now k is just a constant, but x isn't. X is a variable that can change. So if you want to find the energy from a force, you need to find the integral of that force. So if the force is kx, I'm going to write force equals k times x. So that's our equation. And then I want to find the integral of this. So I'm going to type the integral, or let's call it energy, is the integral of the force with respect to x. And again, dot do it. And then I can print the energy, or let's do a pretty print. Energy. So when I run that, you get kx squared over 2, which is your elastic potential energy. That's great. We can do this with lots of things. For example, a universal gravitational attraction, right? Newton's universal law of gravity. That equals g times big M times small m divided by r squared. Okay, so I'm going to have different symbols here. So let's use G and big G, big G. There we go. We got big M, so M equals symbol M. We've got little m, so M equals symbol little m. And we've got R. Now this is a function of R. So what I'm going to do is find the integral of fourth with respect to R. And when I do that, minus GMM over R, which is the potential, the gravitational potential energy in general. Okay, so these are quick integrals you probably could have done on your own, but like I said, you can put in any function you want, and this will do it for you. Very, very quick and easy. So that's our episode on Python, our 5th episode on Python for doing limits, integrals, and derivatives. If you haven't caught the other Python episodes, there's a playlist on my channel. You can go catch it. And also, if you want more resources for doing math in Python and more practice, you can check out my website. I put free resources on there that you can download in PDF. It's youtubephysicsteacher.ca. One word. All right. Keep coding, everyone.